everybody taken the test yet?
No, I have one more.
Oh.
Fifth
We
hour.
have to link them so that we can do tests.
Soon, you're gonna get both tests back. Actually, no, I take it back. Everybody's taken 4, but not everybody has taken 3 yet. I can pass 4 back today. 5-3. We're definitely going to be using this formula that converts an X value into a Z-score today. All we're doing are 4 examples today. You have all the knowledge, we're just going to tie it all together. Okay, car gas mileage for a particular car is normally distributed. With a mean of 28 miles per gallon and standard deviation 1.6 miles per gallon. You're going to randomly select a car of this type. Find the probability that it gets more than 31 miles per gallon. Okay. All right. So this question is asking for find the probability, and we're dealing with the normal distribution. Well, remember, the area under the curve is the probability. So when it asks for probability, it's looking for an area under the curve here. So if we sketch this to see what area we're actually trying to find, it becomes very easy. Here's what I know. The average is 28. I am looking for the probability that the car I select gets more than 31 miles per gallon. Well, that's over here somewhere. 31's over here. More than would be any car in this chunk of the graph. So, what we need to do to find this area is convert this to a z-score. Because once I know the z-score, I can look it up and get the area behind it, and then we can convert it over to the area to the right of it. So, what is the z-score for 31? How many standard deviations above the mean is that value? Well, there's a plug and chug formula right here. 31 minus the 28 divided by that 1.6. And you want this out 2 places, because we're going to look up the 2-place z-score. So round to the hundredths place. Try again. 1.88 sounds better.
1.88.
Yep. Remember, z-scores only go up to like 3. Remember, pretty much. So a 1.88 z-score. So this z-score is 1.88. She'll have a little bit more room there. So if we look up 1.88, what area is that actually representing?
To the left.
To the left. So let's write that down. So positive 1.88. So that's 0.9699. But we wanted the area to the right, so how do you get the area to the right? 1 minus. So only about a 3% chance of picking that car that hits that statistic.
Pretty good.
That's really good. Probably a small car.
Probably flies.
Okay, we'll try another one. So it's all just story problems today, tying together, making you understand what you're finding. Number 2.
Really? Who's that by my house? Yeah.
Time spent
Get that busted the lights on the deer, but away.
in a store.
Way to go find it in the woods. You have to kill it now.
Is normally distributed
At least
with a mean 45 minutes and standard deviation 12 minutes. You're going to randomly select one person. Find the probability that the person spends between 30 and 60 minutes in the store. So again, it's asking for the probability of a normal distribution, that area. So we have to get the answer off of that table. If you sketch your graph, it's going to help you see what you're trying to find. So the average is 45 minutes. But we are looking for 30 to 60. Is that symmetrical around this thing? So we're looking for this area on the graph. Okay? The problem is we can't look up 30 and 60. We need the z-scores for those two spots. So you've got to convert x values to z-scores because the table is based off of z-scores. So how many standard deviations below the mean is this 30? So 30 minus 45 divided by 12. Okay, and because they're symmetrical, the z-score for 60 should come out positive 1.25. I mean, it's not always going to be symmetrical like that, but so negative 1.25 z-score and positive 1.25 z-score. Now what are you going to do?
Positive z-score, positive subtracted by the negative.
Yes, in the between ones, remember you got to subtract the two areas on the graph. So the probability of being between 30 and 60 is going to be the difference in the two areas. So if we look up the 1.25 z-score, 1.25, 8944, and what's the other one? Do a little subtraction. 38?
Yep.
Okay. Easy enough? Let me change it up. Okay. Cholesterol levels. Are normally distributed. How's that? Normally distributed. With a mean equal to 215 and standard deviation 25. You're going to take a sample of 600 men My question is, how many? That's a normal distribution.
It's just getting lazier.
Yeah. How many will have a level less than 170?
That's reassuring there right now.
Oh, it's coming. Okay. So see how this question's slightly different than the last one. The last two both asked for a probability, so we were looking for the area. Now it's saying, I've got 600 men, how many will be in this chunk of the graph that's less than 170? So I shade in that part of the graph. Remember what it means to be normally distributed is if I have these 600 men, let's say they were all ping pong balls and this was a big old rope in a corral. If I drop the 600 ping pong balls in, they're all going to distribute evenly in here. So I'd want to know how many ping pong balls are over here.
Please explain better.
Come on. Think about a great big pen out in the field.
Okay.
You got this rope that's shaped in the normal distribution.
Okay.
Okay? Grab a bunch of ping pong balls, throw them in there.
Why?
Because each represent a person. The number of ping pong balls over here would represent the number of people out of that 600.
I think this is difficult. Wait till physics with Barry. It's a little worse.
Come on, that wasn't bad.
That was pretty bad.
Oh, that is not bad.
7 seconds and then you do the rest of the chapter yourself.
All right. He's telling you things could be worse, so quit complaining.
7 seconds are just, this chapter is hard, and then it's done.
It's done.
Whoa. That's one chapter.
Okay, any guesses on what we're doing here? All it is one extra step from what we did do.
You take your formula, you
Find the z-score for this spot, so we'll start with that.
find the probability.
Find the probability, and multiply. It's an extra step of multiplying. Very good. 170 minus 215, divide by 25. That gives us a z-score of negative something.
I got negative 1.80.
80, okay. So if we look up the negative 1.80, that will give me this area. So off of the table, what's the area for negative 1.80?
0.0359.
So that means about 3.5% of your people would be back here. So all you've got to do is take 600 and multiply by that probability, and that's how many you would expect to be in that part of the curve.
21.5 people.
How many?
22.
About 22 people. So how many? It's one extra step of finding the probability and then multiplying. Yep. Nice short day. I'm done. Yep, that's all there is in here. See how the graph, if you take the time to draw this picture, you'll know what you're finding. Those that don't draw pictures have to ask me lots of questions. Okay. Okay, the length of time worked at a company is normally distributed. With a mean of 11.2 years and standard deviation 2.1 years. You need to lay off the bottom 10% in seniority.
That's just 2.9.
Yep. find the number of years worked and still get laid off. Okay, so if you know what everything is in terms of the graph, super easy. We got 11.2 years is the mean. We're going to lay off the bottom 10%. What is that telling you about this graph?
You need to find Z-score.
For what? What is that 10%? It's the area, correct? What part of the graph is this area at?
It's gonna be in the left side.
To the left side, the younger people, the less years there. So we want this shaded area to be 10% of the normal curve. And it's asking how many years? Well, if you know the area, what can you find off of the table? You can find the z-score for that spot. So let's do that first. So you're looking for an area of 0.1000. I think we did this one right at the start, didn't we? Negative 1.28. Once you've got the z-score, you just use your formula to kick it back into an x value. So negative 1.28 equals some x value minus 11.2 divided by 2.1. And then what are your two algebra steps? Multiply by 2.1, add 11.2. How many years did you work here and get laid off? About
8.5.
About 8.5 years is what I'm looking for.
That would be.
Yeah. Move on.
Whoa, 8.5.
Yep.
I got 8.8.
Oh, I still have one more. I lied. There's 5.
Well, what?
I lied. So sorry.
Fake news.
Fake news. I totally thought this was the last page. I got a 5 here.
How much room is it?
Well, the same as the other one.
I'll make it. Oh, I got it.
Okay. If you go to grad school, because remember this book is a college book, so the example is going on to grad school. If you go to grad school, just like when you go into college, you got to take the SAT. We've got the SAT and the ACT. You take one of those and you get into college. If you go to grad school, there's the same kind of testing you got to take. They're called the GRE and the MAT. So the GRE, it's the Graduate Record Exam, has an average of 1,500 points and a standard deviation of 300 points. The MAT is called the Miller Analogy Test. That has a mean of 50 and a standard deviation of 5. So different schools require one test or the other. You're not sure which school you're going to, so you take both of them. So your scores are GRE 1775 and the MAT of 56. My question is, which score is better? Verify your answer. Why? How do you know it's farther?
You have to find the
More than
z-score.
one deviation.
Yes.
And the other one's less.
More than one standard deviation away. This one's less than one standard deviation. Yes, you're comparing z-scores. You can't compare this score to this score. You can only compare z-scores. So exactly right. Compare z-scores. So the z-score for 1775, and you could kind of just see that it was less than 1, but
Is that what they do with the SAT and
ACT? Yeah, it would, yes, it would be the same kind of thing there. They convert them to Z-scores to see what the equivalent would be. That's exactly what they're doing. And then the Z-score for the 56. This one's 1.2. The other one's 0.92. So, here's your better one. Higher Z-score, better.
Can you move that down a little?
Yep, there it is. Now I'm done. That didn't kill us. Page 2. Yep. 17. It's kind of just using everything we learned. You didn't really learn anything new today other than applying it.
Yeah.
1 through 15, odd.
I wanted to, actually, I have to do this.
Skipping 7 and 13. Yeah, you guys, if you're getting on that fan bus,
Shoot.
get it done in class. This looks really short, but there's like 4 parts to each one.
What are you?
I didn't write the book, so I took out 7 and 13. So just letting you know, don't be fooled.